In the second video for section 4.5, logarithmic functions, we're going to learn about something called the common logarithm. We've seen a little bit of the kind of math that we're going to talk about when we talk about logarithms, but now it's time to see an actual definition. So log x, and it can be written like this, or we can put parentheses around x, is a function that tells us the solution for t to this equation, 10 to the t equals x. So another way to think about log of x is that it's the power of 10 that gives the number x. Next, we'll take a look at a graph for the logarithm. Okay, so now we have a Desmos window open, and I want to graph the logarithm function. And on Desmos, you can just type the word log, and it automatically recognizes this as the common logarithm. So type it in, and we get this graph. So one thing that you might notice is that the graph never crosses over the vertical axis to the left side. That's because there's no exponent that you can put on 10 to get a negative number. No matter what exponent you put on 10, you always get something positive. So that's why our logarithm function is always over here on the right side of the graph. So there's a few things that you should notice, some characteristics. You can see, first of all, how flat the graph is. So over here it's very steep, and then it almost immediately flattens out. And if you go further over, it looks even flatter. So that's one important characteristic. And another characteristic that you should be familiar with is that the logarithmic function is concave down. It's curving downwards. So that means the further over you go to the right, that means the graph is getting less and less steep. Now that we know a little bit more about logarithms, let's return to the idea of the Richter scale. In this example, I want to find the increase on the Richter scale that indicates an earthquake that is 2 times as powerful. So what I'm trying to see is how many multiples of 10 I need to get 2. But this equation looks exactly like this one up here when we were defining the common logarithm. So what I'm looking for is actually the log of 2. So we'll use the common logarithm, we'll do the log of 2, and if you're using a standard scientific or graphing calculator or something like Desmos, it's easy to find the log function on your calculator. So just enter log 2, and you'll see that the answer is 0.3. So this means that if we wanted to indicate that an earthquake is 2 times as powerful, that means that its Richter scale value would only have to go up by 0.3. Here's an important concluding remark. If we multiply a number by 10 to the t power, then the logarithm is increased by t.